When you're deciding whether to put something in your body for decades with the expectation that it will extend your healthy lifespan, the quality and depth of the evidence supporting that decision matters enormously. And here, the contrast between niacin and NMN is not close. Niacin has over 80 years of human clinical trials, randomized controlled trials, long-term observational studies, dose-finding studies, safety documentation at therapeutic doses, FDA approval as a lipid-modifying agent, and real-world use in millions of patients under medical supervision. The evidence base is extensive, layered, and includes the full range of trial phases that distinguish robust science from preliminary signals. NMN, by comparison, has fewer than 20 small human studies as of recent years, most of them shorter than 12 weeks in duration. A significant proportion of those studies were conducted in young, healthy subjects who don't have impaired NAD+ synthesis and therefore represent a population unlikely to show meaningful effects from supplementation. Industry-funded research is heavily overrepresented in the NMN literature, which introduces systematic bias toward favorable outcomes. And the endpoints measured are predominantly surrogate markers, NAD+ blood levels, rather than clinical outcomes like disease prevention or lifespan extension. This is not a criticism of NMN as a molecule with no potential. It may turn out to be an excellent intervention as the evidence base matures. But right now, the evidence hierarchy firmly and unambiguously favors niacin, not because niacin is necessarily superior in all contexts, but because we actually know what niacin does in humans over long time frames, and we don't have that knowledge for NMN yet. Learning to evaluate evidence quality is one of the most valuable skills any longevity-focused individual can develop. The difference between a Phase 1 safety trial and a Phase 3 efficacy trial is enormous. The difference between a 6-week study in 20 young adults and a 2-year randomized controlled trial in 500 middle-aged patients is the difference between a hypothesis and a conclusion. Rodent studies, while scientifically valuable for mechanistic understanding, have a deeply troubled translation record in human longevity biology specifically. There's a practical framework worth applying when evaluating supplement evidence. Search for randomized human trials with clinical outcome endpoints. Distinguish between industry-funded and independent research. Assess study duration relative to the outcome being measured, and ask whether the studied population matches your own demographics and health status. By this framework, niacin earns a high therapeutic confidence rating. NMN earns a low one, not because the preliminary signals are negative, but because the evidence base is simply too thin and too short to draw meaningful conclusions. The warning is direct. Choosing NMN over niacin today on the basis of mechanism plausibility and marketing narratives rather than established human trial data is a bet on theoretical superiority over demonstrated efficacy. That bet may eventually pay off as trials mature. Right now, the evidence doesn't justify it, especially at 60 times the cost.